Hi everyone, my name is Ryan Mibawa. I'm a software developer. I want to show you how to debug the C++ code on the Raspberry Pi Pico board. Okay, let's start the debugging. I have a Picoprobe here and the output on the LEDs. It's as easy as selecting the Pico debugger. Let's run it, start the debugging. All right, now it stopped at the main function. You can see here. And then if we run it, we continue. We can also see the value of the variable. In this case, is the xlet path. It contains 15. That's the GPIO 15. We can also put it on the watch list if we want. So we can always see that. So whenever we start it, we can always see, because we have FreeRTOS symmetric multiprocessing. So we can see if there are instances on the different thread. So as you can see, right now we have the GPIOs 16. So whenever we see this one, this is the LED for that is blinking and running on the core 0. And this one is the LED that is blinking and running on the core 1. So we can start it. And then whenever the LED stop on the core 0, you can see there. We can check the call stack here. And then next, that's the LED turn off on the core 1. And this time we turn on the LED on the core 0 again, and turn on the LED on the core 1. As you can see, we can also stop. We can also remove the breakpoints and then run it. And we can see the progress here on the console. There is a counter that is running on the core 1. You can see the counter. Okay, let's see how do we set it up. Go to my GitHub repository at github.com/rwibawa at pico-FreeRTOS SMP. I got this one from Dr. John Duran. Just follow the video tutorial from him if you want.
Hello, I'm John Durrant.
He also has the sample code. So this is my GitHub repository. We are using C++ code and FreeRTOS symmetric multiprocessing, or SMP. I want to use this template as a boilerplate for my next project. In the future, I want to make it into Pico OS so I can have the good basic operating system for Raspberry Pi Pico. Let's dive in. So to set it up, you just need to clone my repository. And then if you want to know how to set up the Picoprobe, just get it from my video how to build the Picoprobe here. Let's check it out. Another Pico board. Just follow the instruction there. Okay. So in the lib folder, we have the FreeRTOS kernel here. This FreeRTOS kernel, you need to point to this tag, because that's the branch for the symmetric multiprocessing. And then I give you the step on how to get the cmake configuration. The cmake configuration, you need to get it from this path. So if you go to lib/FreeRTOS-kernel, go to portable, third party, GCC, Raspberry Pi 2040, and then you can copy the cmake configuration, put it on the root directory, and then if you want to compare what is the difference, basically you need to get the FreeRTOS kernel path from the environment variable, and then remove the FreeRTOS kernel RP-2040 backpath, because that's gonna be pointing to the wrong path. And then we need to point the FreeRTOS kernel RP-2040 relative path. Okay. So next is look at the main project. Next, the cmake list. We need to enable the console output on the UART because it's talking to the Picoprobe. This is the one. This is the output of the console of our Pico-B. This is our Picoprobe. So we are using the UART instead of a USB, but of course the Picoprobe is using USB to connect to our computer. So you don't need the standard I/O USB in this case because we are using the UART instead. Okay. And then another thing is since we are using the FreeRTOS, we start the scheduler on the one core and then run the tasks on the different core. We have dual core in RP 2040. And then we can start the tasks and we can bind to either core 1 or core 0. So in this case, we create an agent as a abstract class. And then we have two objects. One is the blink agent to blink the LED. And then we have the counter agent, which doing the counter based on the random number. So let's take a look here. This is our configuration. We will have two blink agents. One is using the GPIO 15 that is running on the core 0. And then we have the another one that using the GPIO 16 that is running the blink agent and then run it on the core 1. And we need 4 LED to show the counter. And they're using GPIO 18, 19, 20, and 21. Okay, we can stop this one. And then in the launch configuration, I have two configurations. One is the Pico debug that is targeting the running OpenOCD instance. In this case, is listening on the localhost port 3333. It's already running here. And then the other one is another configuration called Picoprobe debug that automatically open the OpenOCD, which will be the GDB server. Okay, let's try the second part. Let me stop this OpenOCD server. And then we can see the config, my launch configuration that basically start the OpenOCD automatically. There we go. We still have the watch list here from the previous session. You can see that. Okay, now I'm interested with the counter agent. Let's go to the counter agent. So we can see, put the breakpoint here. And then later on, whenever it runs, we can check the usage of the queue later. Yeah, there you go. So let's see. During the initialization is basically it will initialize the GPIO, then set the direction as a GPIO out, and then set it to 0, which turn off the LED. And then we can check. I don't need this one and one. This is actually the status if we receive something from the queue. And then we get the action. The action is actually counter on. And then let's see what is the count. Count is 13 and it's changed. So let's go. And then it will set the LED to count. You can also step into the function set LEDs and then see what's going on there. We have 4 LEDs, right? And then we will set each of the LED pad. So this line will map the value 13 into 4 LEDs. You can see that, right? So we can put I into the watch list as well. So second digit is 0. Third digit is 1. Fourth digit is 1. Okay, and then we are ready to spit out a log message to the standard console. You can see that. So the counter is running on core 1. And then we get the value from the queue again. And the command is still counter on. Still counter on. Okay, that's good. That's good. and then you can keep it running. You can also check something else if you want. If you want to check the register, and of course, you can see the call stack. There are two threads. One is running on the core 0 and the other one is on the core 1 right now. Very nice. You can also temporarily disable all breakpoints and then keep running it. Yeah. You can see actually both LED, they are running at the same time. One is on the core 0, the other one is on the core 1. However, because we put a breakpoint, so they didn't start at the same time. So if we want to take a look what happened, if we start normally, they are supposed to blink together. Let's reset this. Oh. Yeah, as you can see, they are blinking together. And then the counter is actually random. Very good. Oh, one more thing. I also have a new version of the Picoprobe. I'm using a Pico 0 from Waveshare that is actually small and very good for Picoprobe because we don't use all of those GPIO. And also, this is the one that I'm excited about, is the Raspberry Pi Pico wireless, Pico W. So stay tuned. I'll show you some of those new projects with the Wi-Fi. Currently, the Bluetooth is not supported yet. Let's see in the future. Don't forget to visit my technology corner here. You can find me on Twitter, Facebook, LinkedIn, GitHub, and also you can email me or you can subscribe to my RSS feed for the blog. You can check out my blog. And you can find me on Discord as well. Go to the low level channel. We can do discussion. And then you can find some of my picture and project here. Okay, let's connect with me. Thank you for watching. If you like it, please subscribe and share. Bye-bye now.